Okay. Alright, so this question, we're dealing with 8-bit counter. It's set as so 8-bit, okay, and you're given mod numbers here. So the first thing you have to do is to figure out, okay, which one is 8-bit for these mods. So I have the first mod is 128 and the other one is 256. So in order for us to find the number of bits, okay, or number of flip-flops, we're gonna use 2 to the power n equal to mod, yeah, equation. So we get 2 to the power n 128 because it is given here, and then 256 is given right here. Put it in, yeah, and bring this n down. So when we get rid of the base, we call log on this side, and that's your algebra. So log 128 base is still the same too. And put down n, and we're gonna call log, so log 256 base is 2. Then we will go to our Excel and then put that in, yeah. So when you put this in, I show you how to do it. You go equal, yeah, we're calling log. It's set it so please put number, so 120, 126, and then please put base here, so put base right there and then bracket it and enter, yeah. So you're gonna get that, okay. So that's a 6.99, so therefore you need you're gonna need a 7 flip-flop, yeah, 7-bit. The second one is 256, so we do the same thing. We call log, yes, and then 256, and then base 2, and you get 8, yeah. So therefore mod 256, this one is mod 126, I think. So your 8-bit is this guy, yeah, mod 256. So let's go back to our example here. So you will get rid of 128, actually 128. So it's the same thing. So this one got to be log 128. And then base 2, it'll be the same, yeah, still the same. So this is, I should write it, 128, I got it. Okay, so anyway, so 128 is only 7-bit, and then 256 is 8-bit. So let's go back here, so get rid of all 128. So A is not correct and D is not correct. So we're down to mod 256. They're the same. The only thing that is different is synchronous or ripple, yeah? So let's continue to read the question. So it said the clock input to the first stage. So LSB is your starting stage because it's the least significant bit out of 8, okay? We're gonna start with my first bit or your first flip-flop. And we're gonna put your system clock, yeah? So here is my clock line here. It's going to go into the first LSB, which is your first bit here. And then the question said each stage, right, output is used as the clock input to the next higher stage. So here, my higher stage, and that's my lower stage. The next stage is higher than the first stage. So the output of the first stage is going to become the input to the next stage, okay? So and so keep going all the way to the 8-bit. So since the clock is going into only the first, right, stage, they use a stage here, flip-flop, the same thing, or bit, that would be the ripple counter, yeah? Ripples are asynchronous. So when you carefully look at this B and C, the answer is C because it said so mod 256 satisfy your 8-bit, and then ripple satisfy asynchronous because your clock will go into only the first bit, yeah, the first stage counter, yeah. So your correct answer is C here. if you have like a, let's do the review here. Yeah? If you have your clock going into each, okay, stage like this, right, at the same time, that would be synchronous. Okay, so my drawing's not very good. Anyway, so you got the idea. Yeah, so if your clock line is like this branch, yeah, you have so many branches to each flip-flop here. So I have 1, 2, 3, 4, 5, 6, 7, 8 branches here, and we apply the clock input to all of them at the same time, yeah, to cut the times. Then that would be synchronous, which is this guy. Yeah. Right now we are asynchronous, which is your ripple counter. Alright, so that's it for this question.